Hi. Nearly 7 lakh people die every year due to suicide, that is one person every 40 seconds. So in this hackathon, along with the physical fitness, we will also be focusing on the mental fitness of the users. So in order to solve this problem, we are here, Team Code Titans from Thakur College of Engineering and Technology. The problem statement on which we will be focusing on is fixed scope, that is to use non-invasive health monitoring and diagnostic methods. The first step for our solution will be the data collection. So here we'll be using the camera and the computer vision for determining the heart rate through it. We'll be using a BIA sensor for determining the body composition like the BMI and other things. We'll be using a ECG sensor for accurately predicting the heart rate and for training the model so that it can accurately predict based on the computer vision. Since computer vision on the solo basis cannot accurately predict heart rate because it works on data. And for the data, we'll be using ECG sensor for collecting the data from the user, and then we will apply deep learning on that and regression and other models on that in order to create a model based on which we will be able to accurately predict the heart rate just by using computer vision. Then comes the PPG, that is photoplethysmography, that is used for determining the oxygen saturation of a person. Then comes the temperature sensor. This is we will be using for keeping a track of a user temperature so that we can predict and we can understand if the user currently is under any critical condition like fever or not. Then comes one of the most important parts, that we will be using CGM sensor. This sensor will be used to determine the blood sugar level, and this feature has not been added by any company by any watch till today. So based on all the sensors which I have talked in the previous slide, all these attributes will be stored in the database. We will be using Firebase for now for storing all these attributes. First is the HRCV. This is the heart rate through computer vision. Weight of the user, body fat percentage, skeletal muscle mass, fat mass, BMI, body water percentage, basal metabolic rate. All All these attributes will be found with the help of the BIA sensor. This heart rate will be found through the ECG sensor. This temperature will be found through the temperature sensor. Oxygen saturation would be found through the PPG sensor, and the sugar level will be found through the CGM sensor. So the first feature is the diet predictor feature. Based on the sugar data and the calorie intake of the user, we will predict and recommend diet to the user based on the data stored in the database and the sugar data and the calorie intake of the user. The second feature will be a fever alert. Temperature and oxygen saturation will be tracked in collaboration with each other. If the temperature of the user exceeds a certain threshold value and if the value remains high for a certain period of time, the notification will be sent to his phone as well as to his family members for person safety. Then comes the heart attack alert. Based on the heart rate data, sugar level, oxygen saturation, and body fat percentage, it can be monitored and it can be predicted whether the user can have a heart attack or not. And an email notification will be sent to the user as well as to his family members, and the data will be sent to his family doctor as well. Low calorie notification, the user's calories will be monitored at each time at a duration of 5 minutes. And if the calories of the user seem to drop below a threshold value, then a notification will be sent to the user. High sugar alert. Every 5 minutes, data will be collected from the CGM sensor. And if the sugar level exceeds 250 or so, then a notification alert will be sent to the user to keep an eye on food and calorie intake. And the diet will also be predicted, which we will be dealing in the future slides. And then the user can decide what to eat and what not to eat based on the diet which is predicted. The main feature which we will be working on is the dashboard feature. We will be collecting the data on timely basis like every 5 minutes from various sensors, as well as we will be collecting the data from the user on a daily basis for tracking his mental fitness. The data will be used to plot a graph which will be shown on the dashboard when the user will download the Titan app on mobile or use web application on the desktop. Linear regression, support vector regression, and neural networks like RNN, CNN and LSTM will be used. Coming to the model training, this will be using to predict the heart rate based on the past data of the user which we have collected through various sensors and through using computer vision. So the next step is to design the neural network architecture suitable for ECG data analysis and for the computer vision data analysis as well. Several architectures can be considered depending on the specific task and complexity of the problem. For now, we will be using recurrent neural networks and specialized variants like long short-term memory (LSTM) networks for ECG data analysis due to the ability to capture temporary dependencies in the data. We will also be using convolution neural networks to learn hierarchical representations of the ECG signal, particularly for detecting specific waveform patterns and abnormalities. Training the neural network. With the prepared ECG data and designed neural network architecture, the network is trained using supervised learning. Training involves presenting labeled ECG data where each input has a corresponding target output, such as heart rate or cardiac condition, to the network. The network adjusts its internal parameters, weights, and biases based on the chosen optimization algorithm, example gradient descent, to minimize the difference between the predicted outputs and the actual target values. The training process aims to optimize the network's ability to accurately predict the desired outputs from the input ECG data. Coming to the evaluation and validation part, once the neural network is trained, it needs to be evaluated and validated using separate test data that was not used during the training. This step assesses the network's performance and generalization capabilities. Various metrics such as accuracy, sensitivity, specificity, or area under the curve, that is the ROC curve, will be used in order to detect the accuracy of the model which we had built. These are some of the graphs which we had plotted using the Google Charts API and collecting the data from a watch's sensor and storing it on Firebase. This is the correlation matrix for the heart rate data, that is the data collected from the sensor, that is the ECG sensor, as well as from the camera using the computer vision. So this is the correlation matrix and this is the graph which we had plotted till now. Coming to the part work done till now. So currently we were working on computer vision, that is detecting the heart rate. So this is a computer vision part which we will use for tracking the heart rate. So currently determining my heart rate based on my face color, that is the color which is changing, and it is comparing the data, that is each frame, with the data set, and then it is displaying the heart rate. Now it won't be that much accurate. So what we'll be doing is that, for example, this is the data which was collected from the ECG sensor. So suppose if I get this line, with the computer vision. So now this is the difference which we need to tackle. In order to tackle this difference, what we'll do is that we'll calculate the correlation between the two, and then we will plot another graph with the help of it. This is the another graph. Now, suppose for a particular timestamp, this is T, for a particular timestamp, if we will get a value of heart rate, now at the same timestamp, this is the difference. So we will increase this value by this much amount. So now this will be the new value, but it won't be that simple because we will be using all these data along with each other to train the deep learning model, and based on all these data, this graph will be plotted, and hence it will be much more accurate, and it will depend on all these attributes. So at a particular timestamp, with the help of all these attributes, this data will get predicted and the data will be modified accordingly, and hence the data which will be collected with the help of the computer vision will be given to the model, and the output which we will get will be given to this model, and then we will get the final output, and that final output will be stored in the database. To camera. So this is its implementation. This is the heart rate which we are getting from the sensor. So these are the heart rates which we are currently getting from a watch's sensor, that is the ECG sensor. This is the diet filter on which we are working on. First of all, we are using the GPT API, that is we are sending the request to the GPT and then we are getting the response from it. And then we are giving it the data which we have stored on the Firebase, that is the physical, sleep, mood, social and stress and heart data which we have obtained from the user from the dashboard. We'll be seeing it soon. So this is the dashboard. If I simply write the username here, so all this charts gets displayed here. The user can add one value daily, not more than that. For example, if its heart rate is 56, its mood value is 9, social interaction value is 2, stress value is this, and physical value is this. So if I'll submit, so it shows function successfully entered today at 6:44. You can enter the values again tomorrow. Now the user won't be able to enter it today. So these values got successfully entered here. Those values which were entered by the user were stored in the Firebase database, as we can see here under this SHA section. For this user, all these values are stored here. For, for predicting the diet, we'll be using the same data stored in the Firebase. That is now here we are getting it from the Firebase, and then we'll be sending the response, the query to ChatGPT in this manner, and then we'll be getting the response and we'll be sending it to the API, which will be printed in the front end. This is a sleep data, that is really tracking the total time the user sleeps, it is awake, light, deep, and so on through the sensors. So the task. This task was using computer vision, which was using TensorFlow and all. So all these tasks are highly computer intensive, and this require a very good processor. So all these processes cannot be processed inside a watch. So what we'll be doing is that watch will simply collect the data, that is the video of some 2 to 3 seconds, and the watch will only work to collect the data, and the data will be sent to the data centers or the virtual machines, and all the computations will be performed on the virtual machines, and then the data would be seen by the user instantaneously, and it will not require that much time. It will only take 2 to 3 seconds for the computation to be done and to be sent back to the user. Coming to the tech stack which we'll be using for front end, we'll be using HTML, CSS and JavaScript. For backend, we'll be using Python. For AI and ML, we'll be using linear and logistic regression, support vector regression, and neural networks. In neural networks, we'll be using RNN, CNN, and LSTM. The hardware which will be required is as follows: ECG sensor, BIS sensor, camera, PPG sensor, CGM sensor, and the temperature sensor. So that's all from our side. Thank you so much.